Today on Captain Chaos' Laboratory, we're doing the Yummy Gummy Gumdrop Factory from Department 56, the North Pole series. I don't think it has a date. 2004, so it does have a date. And this uses a split power supply right there. So this plugs in here. Boink. And this one plugs in here. You can kind of hear the motor, but the gumdrops aren't moving and these aren't turning. So we are going to see about repairing this. So I'm going to unplug the power supply. Now on this one, just doing a preliminary look over of it. This is a little porcelain house, and bottom solid, back solid. The top piece here is plastic, and this piece here is plastic. This gray panel, and I can see the glue seam all the way around. So to access it, it looks like we'll have to take the front off, or yeah, probably the front, because porcelain, resin, plastic. And I don't think I want to try and take the stacks or this top piece off. It looks like the big seam is right here, because I can also flex it. So first thing I'm going to do is I'm going to just put a little pressure on it with a small blade screwdriver and see if I can see if the glue joint's going to let go because of its age, or if I have to get some heat going. And I need to find out if these just slide off. They do. Alright, now give me a second to see what the dog's barking. But yeah, you're going to have to pop out the wheels and use heat. And I'll be right back. Sorry about that interruption. Apparently there was a cat. So let's get the rest of these rotating wheels out, which there's the 3. That one doesn't want to come as easy, so I'm going to use some 45-degree bend pliers to get behind the thickest part of the plastic and then see if I can get it to pop off like that. So let's get those out of the way. And now I have a little bit more flex. I do have, I'm going to get the heat pen going. So we're going to get that fired up here. I'm going to set it at a low temperature to start, which is 100 degrees Celsius, which is the lowest setting. There we go. I'm hoping this will soften up some of the glue. My biggest concern is this arch right here, because this one's not glued on, but this one is. And I believe the glue they use has got a higher melting point than the plastic. So I'll do my best to get it to separate. So there we go. So it is actually starting to separate. I don't think I'll need the glue gun. did get enough of it to soften up with the heat to get it to start to break free. There we go. And I see we have some snow bound up in the mechanism. I was told that may be part of the cause or the entire cause. And then this one's kind of glued on cattywampus, but it is also the axle to hold this other pulley in place. So let's put it back in and see if it actually turns now. Real quick, I'm just going to look under this plate to make sure there's no other snow. There is. So if you have fake snow around your villages, just be careful with it. Like I said, the owner of this said that's probably what caused it to stop, most likely. Let's see, pull this side. Pull this axle back out before I turn it on because I want to try and get this to rotate and see if I can get some of the snow out. This is the drive side. This is the I guess you call it the slave side or the idling side. That's why the axle stayed in here and this one comes out. So let's push it back into place. See if we got enough of that snow out. Get it all the way in. Plug in the supply and see if it actually rotates. It does not. Okay. So, let's try it again without that and see if I can get the pulley to turn. Even the pulley's not turning. Okay. So now we need to get farther into it and see if we have a broken gear or something. I'm trying to see how this is assembled. There's something holding it in the middle. There's resin down here and a couple screws. Let's take those screws out and then we'll see if we can crack the resin or heat it up and see if that'll separate the guts of this thing. So here's one screw. And oh, look, the whole thing comes loose. Look at that, 2 screws. Alright, let's turn the air back on here. See if we can get this resin to soften up. I have my heat set now to 130 because the resin is a little stronger than the glue. I wanted to see if I can get, and it's also thicker. I want to see if I can get this to break free. I'm glad I didn't put lights inside here because that would have made it more difficult. It probably look cool, like the lights that are in here. And it's actually pretty neat. These actually look like real gumdrops. They're probably just as hard. So I'm just moving it back and forth until the resin changes the reflectiveness. As it's getting hot, it's getting shinier. I normally use spudgers, but I don't think the spudgers have enough strength to move this stuff. Not enough. Whatever resin they use is definitely strong. If I bumped my machine up to 190 C, I think that's like close to 400, a little under Fahrenheit. This some strong stuff. It's porcelain to plastic with this nice thick resin bead, and the plastic's getting really pliable, but the resin isn't. That's my problem. The plastic's becoming very flexible. It's also very, very hot. Let's see, it's maybe just enough flex that I can get this out. Alright, so I have flexed it enough to get this to break free, at least stick out part way. I have no idea what the dog's barking about now. It looks like it's a direct drive. It looks like the motor just goes right through. So I wonder if the motor is bound up. It's almost out. But I think it might be out enough. I can get the belt off. We can get the one pulley out. Oh wow, yeah, there is just stuff impacted in here everywhere. So this right here is another idler, and it doesn't turn as easy as it should because of all this fake snow. I don't think this is the reason the motor's not turning very well. I think this is just stuff that's going to slow it down if I can get the motor to function correctly. Quite a bit of snow. Trying to, it's wrapped so tight around the axle, I'm trying to cut it up against the axle to get the rest of it off. There we go. turns a lot better now that there's not near as much crap wrapped around it. This might just be most likely a video on how to clean the stuff that gets caught inside your house episode. Alright, let's see if I can get the belt all the way off. Resin plate's gonna have to either come out or flex some more. Break free. Gonna have to flatten that back out. But is that enough to get the motor out? No. I understand why they use resin, but I'm going to tell you, it makes it really difficult to get stuff out. This motor is a super tight fit. It's a zero tolerance motor, meaning there's zero tolerance. It has to be pretty much perfect to get it out. See if I can shave down some of this resin. Now, I can actually unscrew this to get the front and rear plate apart. Letting it cool down, that's why I had it running. So we can get the rest of the gunk out and see if we can get this motor to turn. Here's the idler in the middle. That is actually quite warm. Let's get the rest of the snow off of it. Oh yeah, it's just wrapped around this shaft. There we go. Now, let's see if it spins on its own. It is struggling. I think the motor might have got damaged in the process of, well, of sucking everything into it. Let's see if I can get this pulley off. There we go. The motor is 5.6 RPM, 2.5 watt, 12 volt AC CCW. Since that sticker used to be on the back of the motor. Now, I'm going to unscrew the motor. Clean off all the snow. There's more of it coming out. At least they gave you a lot of wire. Just have it coiled up inside, so that's a definite positive. So then you can get the motor out. Okay. Says it does 5 to 6 revolutions per minute. I don't know if it's even doing that at the moment. So, what I'm going to do is I'm going to mark this hole with this stud right here. Let's see how fast this thing is actually going. I think I have a stopwatch on this thing somewhere. Right there. And it is turning. You can see it is turning. It's just really slow. And this motor, it almost feels like it's struggling. We're at 12 seconds. I don't know how fast this is supposed to turn. I guess I should find a video on it. We're at 30 seconds. 40. Might be doing 1 revolution a minute on the outside. I don't know if they're rating the 5-6 RPM at the shaft, which they should. So we are at 1 minute. So it does 1 revolution a minute. So it does work. And this back here unscrews, the face unscrews, and then you can take this out because this port in the back only does the motor. But it is loose, so I'm just going to quickly tighten it with my finger. And probably use a blade screwdriver to torque it down. There we go. So this is the lighting, and the port in the back is the motor only. So it is working. It's really slow. I'm assuming it's not a very fast unit. So now let's try and reassemble it. So first we gotta pull this thing back apart. Also helps if you actually have it facing the right way. So, push it back together, make sure the splines line up. And it's nice if you can get it apart, they give you alignment tabs so you can't put it in backwards. Apparently you can put the motor in backwards, which was what I was trying to do. I want to assemble it and make sure it actually drives the belt. Kind of surprising to see, as old as this thing is this belt is still very pliable. A lot of the ones that have belts, they seem to, the belts get brittle and vulcanized. They don't flex as much. There we go. Axle's all the way in. Screws are all the way down. Yeah, it can't turn it. Too much tension. So the motor is shot. That's why it sounds so horrible and it's spinning so slow. So I need to locate a motor. I'm just going to loosen up the tension a hair on the bracket and see if that changes anything. Now, I think the internals of the motor have cracked. They're a high torque motor, they don't like to be stopped. And I think when all that snow got bound up inside, it broke the internals of this. Glitter everywhere. I need to find my calipers and need to measure the outside diameter of that motor, because I'm sure, like this motor here, it's a 12 volt AC, you can see much bigger, much bigger. So I'm going to have to locate the smaller 12 volt AC motor. I don't think I have any. I think all mine are the large. Let's see, what's this guy hiding back here? Oh, this is a 12 volt. This one might work. The shaft is a little excessive. Don't get me wrong. I understand the shaft is much longer, but you could probably trim that. Seems I don't get very many quick and easy repairs anymore. Where they used to just be you open it, figure out how to open it up. Once you open it up, it's just a standard motor or a belt or a gear. Seems like everything requires modifications or fabrications of parts, which makes for a simple, what seems to be a simple task to be a very long repair. So, also, this pulley isn't supposed to pull the center of the motor out. This shaft should not come out. It should be sliding off the shaft itself. So that's also a concern. Looks like the shaft diameters are the same. The bushing's different. Diameter is about the same. This one's slightly faster, and the original is a 12 volt AC, 50, 60 hertz, which is standard. A 2.5 watt, 5.6 RPM CCW. This is a 12 volt, 50, 60 hertz, but it's a 4 watt, so it's slightly stronger because it's a 5 RPM. It's a solid 5. So same basic speed, slightly more power, which means if this thing gets wedged, it's going to either spin it until it breaks or it's going to just internally destroy all the gears that are attached to these pins. But this one is a CW, CCW, which means every time that you turn it off and turn it on, it's going to reverse directions. So one time it'll go to the right, and the next time it'll go to the left, and then the right, and the left, so on and so forth. That's what CW and CCW means. It means clockwise and counterclockwise. It's getting harder and harder to find just one style, meaning just CCW or just CW. Most everything is now both directions. And that is because if it gets jammed, it'll turn back and try and unjam itself. But I have this, and you might be able to modify this to fit in here, cut the shaft down, and hopefully that'll take care of it. Now this was pushed into here, which does fit in there, but I don't know how far in this hole goes, and I'm sure the splines on this are different than the splines on this. But when you pull this out, this is supposed to be separate, so I'm going to have to beat out the center. Let's see if I can tap it out with the handle of a screwdriver. fits in there pretty good. There we go. So I'm holding the shaft with a pair of pliers, as you can see, and I'm spinning it free. Yeah, because this piece shouldn't pull out. Yeah, it's the same. So where my issues are going to lie is, besides the height, which we can cut with a Dremel tool or a saw, is this spacer bushing. This spacer bushing is going to pose a small problem. See, it won't go through. 1, 2, it's going to push everything out. Now, we can try and trim this bushing. You can use a razor knife and cut around it until you hit the metal and pop it off. 2, you can take this hole, drill it out to where it fits over the spacer bushing, because the piece of plastic is almost as thick as the bushing. Or 3, if they were both the same brand, which they're not. This one's a An Yi, and this one is a TYC, which are the standards anymore. You could try and pull the shaft and replace the shafts. Normally how you do it is you have to open this up and press the shaft out. You should not be able to yank the shaft out. That's the point of it being the way it's built, is to make sure it's strong. And pulling a shaft out doesn't make it strong. It means that there's a weak point. So anyhow, what I'm thinking about doing is, first I'm going to test to make sure this actually works. And the reason I want to do that is because if you saw my Octo swing, that thing took me forever because I got defective motors. Now when I bought the synchronous motors, because they were running low, I bought a couple. This is my last one. And just to make sure that they're still good, we're going to hold one wire on the bottom of the barrel and one wire on the top. And she's spinning just fine. You probably can't see it because there's nothing to give you an indication it's turning. And she's really quiet. I don't know if you noticed that too. It's not making any major sounds. So the next step is I want to drill this out to the next size bigger. And I want to try and keep this plastic bushing, because this is a higher torque motor. The wattage is where you get your higher torque. I want to try and salvage as much of this bushing as possible to prevent excess wobble in the shaft. So if I can make this bigger and slide it over, the motor will still be reinforced, and I may only have to trim a hair off of this. Possibly not, because the center axle point where the axle goes through on the back side is recessed from the outer edge of the gear, or semi-pulley. On the front side, they're the same height. So with this back side recessed a little, it might be perfect. Let's hope. So first thing I'm going to do is find a drill bit and drill this thing out real fast to where it slides over. And then once that's done, I'm going to reassemble this without I don't need the gears, I just need this part in here like so, into its little grooves. Don't even need the screws, because once it's in and it's lined up, I can then mark what is flush with this outer plate, and I know where to cut. And once that's done, then I can mark, once this is marked, I can then use a Dremel tool with a cutoff wheel. You can use a hacksaw. Hacksaw may not be as clean, and then trim it down. Now I'm hoping this shaft goes all the way in, and I have a funny feeling it doesn't, because, you know, Murphy, why would it? So here's a motor with a piece of wire. Let's see how far in the wire goes. Does it go all the way in, or does it only go in a half an inch? Well, it goes in that far. So that is going to pose a problem. The problem being is I need it to go in where I can slide this into it. So I'm going to have to, before I cut it, get a drill and drill down in here. And the reason I want to do it before I cut it is because once you cut it, you may not cut it perfectly square, especially if you're doing it with a Dremel tool. If you have shaky hands or bad eyes, you're going to cut it at a baloney cut, basically an angle. So I need, and plus, I can use this center hole, which only goes down a little farther than this step. I can use that center hole as a guide to guide the drill bit all the way in. Now, you need a good quality drill bit. This is hardened metal. This stuff is hard to drill through and cut. So, don't buy some of them cheap bits you get at the Harbor Freight for $20 for 500 drill bits. You're going to smoke the bits and you're going to get this extremely hot. The metal part doesn't care about the heat, but the plastic parts that are inside here, because there's plastic gears, they care about the heat transfer that goes all the way down and inside. So you want to get a good metal cutting drill bit. If you just go buy a single one over at the hardware store, I usually go to Ace Hardware. You can go to True Value because they sell single bits more often than you see at the big box stores. But you want to make sure that you can drill down, and you're going to have to mark your drill bit. So if I just compare the two, I need to drill to right about here. So if I lay a drill bit along the side, I need to mark the outside edge of the drill bit with a Sharpie or tape, which is the most common. So I have a stopper, so I don't continue to drill all the way through, and one, transfer more heat into the base of this, and two, not drill so far that I can actually punch through and get into the internal mechanisms and possibly damage them either with the drill bit or the shavings. Next, you might have to use a oil, a lubricant, a cutting oil, something, and dab it in a hole and work your way in. Go in, pull it out, clean it, go in, and that's because the flutes of the drill bit may not have enough to pull it all the way out and keep the hole clean as you're drilling it in. It sounds really overcomplicated for what it is. It's not as bad as it sounds. It's just a way to protect the motor, because if you're going to buy these motors by themselves, they're going to run you $10 to $20 a piece, and you don't want to screw it up and say, well, there goes a $20 bill, and have to go buy a new one. In the old days, these things were cheap, but you know, it's post-COVID season, so everything's more expensive. But you want to take your time. So before I do a lot of it, I'm going to go and drill this hole out. So I'm going to go find my high-speed, good metal quality drill bits, chuck it up, and then slowly bore all the way through to right about there, so that this right here can sit where it's supposed to. Once that's done, I'm then going to slice at the mark of here, and then this shaft will be prepared. Now, of course, before I slice it, I have to drill out this hole so it recesses around the bushing. So bear with me for a little bit. I got to go find my drill bits so I can drill that out. And of course, I need to drill that out and then cut the shaft off. And then this, not quite as long as this wire, as you can see. This wire is just soldered directly to this port. So you could unscrew the port and solder it, or you could cut the wires and then junction them together with a butt connector or solder joint heat shrink. It's personal preference. If you want to make it cleaner and less likely to fail, solder it directly back to this port, which again just unscrews from the back and you can pull it out. The excess wire that you saw they had tied, and then it was tucked over here in the corner, so you don't really have to do anything special. I will probably unscrew it and resolder it to the actual port and go from there. So sorry for how long this is taking for what it is. Hopefully we'll get this thing fixed up here shortly, since we're already into this about 47 minutes. And there's probably still another hour or so, which I'm not going to film all of it. I'm not going to film the drill because I'm going to do that outside. Because if I use cutting oil is really toxic. It smells horrible, and I don't really want it in here. And I'll probably end up cutting this outside so it throws all the metal debris and not all over my bench. And so, but anyhow, that's where we're going to stop at the moment. Be back in just a few. All right, so I bored the hole out so that fits, and then I took a red marker, once this is lined up and centered, and marked the shaft, which also puts a little on here, but it's below the sight line. So now we're going to cut it. I did already drill through, so it's not long enough to show you that it's all the way down. Just use a micro bit. So if I pull it out, it puts the hole flush with the top of the white bushing. So it is drilled out. So now it's time to cut it. To do that, I'm going to use a Dremel. So what I'm going to do is I'm going to chuck this up in a vise. And instead of chucking the motor up and risk crushing or bending the motor or the pins, I'm going to put it here on the part that's going to be scrap, and then cut straight down from that red line. And then we'll have a short motor that we can stick in here to imitate this one. So that's where we're at now. I just want to give you a quick show that it's getting there. And we'll be back with the next step here in just a moment, because the Dremel cutting through this steel armature is going to be ungodly loud. And again, I'm going to do it outside. So be back in a moment. All right, so here it is reassembled. There's the motor screwed on, belts on. It's all back the way it's supposed to be. And then if I take the power and hold it down there, there we go. So that's taken care of. So I just replicated that with a saw and a drill bit, and actually a couple drill bits because I drilled the plastic out. So there's the nose, the shaft that I cut off, and you might be able to see there's a hole. That's the out of the drill bit, and that's the in threaded part. So this part is now done. Now the next part is fixing this plate. I'm sure you saw that the plate, because I got it so hot, tore in half. And you might notice this blue piece of plastic that just magically appeared. Well, as you can tell, this is a jewel case insert. Look at that. So for any younger people, this used to be what held a CD or DVD. But anyway, what I'm going to do is take this and get the approximate measurement by folding it flat back out and then tracing it onto here, drilling the holes, because this plastic is almost the same thickness and it's got a little bit of flex like this does. And I don't care about the color because it's going to be below the sight line inside here. So I'm going to flatten this out, draw out a new one, cut it out. The most important part of the whole thing is the hole placement right there. So random junk, like I said, that's our channel. And cut that out, make sure it fits, doesn't interfere with the gumdrop conveyor. I did not chisel this out yet. The resin, it's a track, it looks like this from above. That's so I can slide this in to make sure it's centered, and then I can just fill this in with super glue or resin glue. I'll use super glue because it's easier to take it back out if need to. So that'll be the next step. And I'm going to unscrew this piece and solder these directly to the back. But I want to do this first for alignment. And then once I know the alignment's good, then we're going to do some soldering. So I'm going to get all this prepped right now so we can get this cut and measured and tested, and then we're good to go. So there it is, same size as this one. The wing for the screws is just a hair off. but it still screws in and it self-centers. Don't over torque it. You don't want to strip the plastic. This was glued on at an angle, like I already said. I'll probably just leave it like that unless it interferes with the house when it turns. Then we'll heat it up, pop it off, and fix it. But yeah, there we go. There's a little closer up view of it reassembled. There's the idler shaft. That basically the belt just rolls that, which rolls this, which then turns the little wheel. So, and just so you know, that fits in there. Okay, perfect. And actually, I used the same size drill bit as here, so there's less slack, so it's guaranteed to turn and not slip. So the hole is one size smaller than the OEM hole, just to have a slightly tighter fit. So you don't have to do that, but I want to make sure that all three of the pieces turn, as well as our gumdrop pulley. So there we go. And here's the Dremel brought in with a cutoff wheel, and that's how I cut that off. And then a drill with that micro drill bit that I use to push all the way through. So not terribly difficult. You can do it with a hacksaw, like I mentioned, but this will do it faster and slightly cleaner, and as you're cutting through, it'll sand down any burrs. So, but I'll probably be using this, I don't know why I started taking it apart, to cut this plastic, because these cutoff wheels work good for that too. So, anyhow, let's get the next stage prepped and get this thing up and running again. So, be back in a moment once we get everything prepped up here. Okay, so I did a rough measurement of this piece and just cut it out using the Dremel with the cutoff tool. Now I'm using a X-Acto knife to remove the burr, because most of the times when you cut plastic with a rotary tool, the heat from the friction generates a burr. I use the spudger as a straight edge, and I'm just basically making a rectangle. Now, if you can get yours out without having it break, more power to you. I was poking at it, and I'm afraid of breaking the porcelain. The resin is that strong, so I don't want to crack it since it's an older house. Now I'm just going to go around and smooth over the edges so they're not so squared. Go. I also did unscrew this, so this can be soldered onto this. Because it's AC, it doesn't need to be in one direction or the other. There is no polarity issues like on DC, where you have a positive and negative. AC, of course, is alternating, which means it's both on both sides. So set this over here for some other project that might need a piece of plastic. And it slides right in because it's the same thickness, like I was saying. So I did put a small dot where this one hole is. I just guesstimated by placing it here and there. That one, my marker tip is too fat, so I'll probably use a pencil tip, and then we'll drill those out. So I can see the pencil tip, and bear with me. I gotta take this call. All right, sorry about that. I'm on call this afternoon. So I gotta answer the phone, but I figured I'd try and get this finished while there's dead time between the phone rings. So now I have the holes marked. What I want to do before I drill anything, get this swapped over, set this inside, and then make sure my alignments are good. So, gonna need a soldering iron and some solder. Over there. First thing to do is I'm going to tin the new one. There we go. So the new one's tinned. Now we need to remove the old one. And the easiest way to do that is to add fresh solder and then desolder. So, and then one. And two. So there's the bad motor. And here's the new one. There's one. Normally it's not this hard, it just keeps moving on me. Should probably use those helping hands. Here we go. And two. There's the part that holds it in. I'm going to slide this back through. Now, if you don't have the ability to solder, or you don't know how to, you can just cut the wires, strip them back, twist them together, and either use heat shrink or liquid electrical tape or even hot glue to make sure that they don't touch anything. Or you can use a butt connector and connect them together. But if you can solder them back to the power port, that's your best bet. Always the hardest part once you get it back in is once it's just got to get that first thread. Once you get that first thread, you just got to spin the outer edge. It's got two notches. If you have a thin, wide blade, actually the spudger might work. It's thin and wide. Oh, look at that. That works even better. That can span. You can then just screw the face on. Some houses I've seen them put a dab of glue. So this doesn't unscrew. That's up to you. If I'm having a problem with a specific house where this ring keeps unscrewing and the port falls in, then I will put a dab of glue on the threads. But what a dab of glue does is it also makes it hard to take it back out if you ever have to work on it again. So I'm hoping this motor lasts a really long time and it never has to come back out. But you can put a very, very, very small dab of glue right on this inner edge where the last thread's protruding, and you're fine. You can do it on the inside too. That one's a little harder because then you have to get in here and break it free with a screwdriver or a spudger. Not that style, but this style. Whereas if you do it right on the outside edge, as long as you don't get anything in the actual barrel hole itself, you can do that as well. See if we can finagle this guy back in. Should go in easier than the old one came out, and it does. There we go. So now we just need to get it up against that plastic. I should have shown it closer, but we'll try. There's a little ledge right in here that this back plastic sits against. So I want to get it up against that ledge. That. There we go. And then that way I can verify that this piece of plastic is correct. I think it's slightly too tall. Let gravity help me here and put it on its back. There we go. And yes, the plastic is good. So my holes appear to be good as well. You can use a power drill. You can use a finger or thumb drill. I'm probably going to use a thumb drill because my power drill is out in the work van. I forgot to bring it in. So I'm just going to see if I can drill the holes real fast. And then get the holes lined up. Once the holes are lined up, then make sure this is trimmed to the right height and width I need. Get it to set in. Make sure everything works without binding, and then glue it back down. What I'm doing now is I'm just making sure that the screws actually go through. The threaded part is the white piece. So if your hole's a little tight, meaning that it tries to make its own threads, you can easily just stick the screws through, and then at the very end just keep turning them, and that'll clean out the thread. The thread will act as an auger or a sander and clean out the threads, so you don't have to worry about them being stuck. So there's that. Depending on if you're a crafter or not and you've watched videos, you can also make these holes with a soldering iron tip, a small tip, not a fatter tip like this, and melt a hole through. That works. I'll do that in a pinch, especially if I can't find the right size bit, but it stinks. So it's a very, very, very smelly process, and of course when you're melting plastic, it's very toxic. So down. This is where we're going to have the fun. I need to slide it under the gumdrops, up, 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 under, then back down, and you got to get the drop into the pocket that's left from the resin. Now, if you can get yours completely out, then you don't have to do this part. You can just glue it back in where it's all in alignment. But apparently all I did was melt the plastic. Oops, too far over. There we go. So now it's back in. Now I need to make sure my holes line up. Of course, my gumdrops are right where my screws go. Apparently my screw holes are slightly too high. Not a problem. That's why we're doing a test fitting. They're in the right spot, but this edge is too high. So when I extrapolated these two pieces together, I apparently went a little bit too high. So I'm going to see if I can trim this with a pair of sharp scissors versus the cutter. Give me a minute. Gotta answer the phone again. Alright, yep, using a sharp pair of scissors worked perfectly to trim off a little bit of extra. There you go. So, now I'm going to use hot glue after thinking about it in case this happens again. It'd be a lot easier to disassemble than using a hard resin, because that, where the blue is now, where that white piece used to be, is going to be a lot harder to remove, to pull this apart to clean it out and or replace the motor if it breaks. So I'm going to use the Sure Bonder hot glue, which is a much stronger bonding glue, and hot glue the blue plate to that resin. Now this resin is nice because it's acting, like I said, as a lip for it to fit in and hold it. So I can just drop it in, and then I'm going to just Sure Bond around it. So that's probably going to be the best choice. I'm not saying the person that owns this is going to do it again, but stuff happens. You know, and then I'll use the Sure Bonder and put a dab of glue on each side and stick it in. I guess we should probably remove the glue remnants that are on this one. So clean it up a little bit. That way it's nice and it bonds better. But so just a quick recap before we fire up the glue and get it going. If for some reason it fails, either the motor dies or you happen to pull snow into it, you can, well, you have to remove the front with a little heat and some prying. This one was glued on the two sides and the bottom. I'd recommend when you put it back in that maybe you only glue the two sides, not necessarily the bottom, unless you're having a problem with it flexing, just so you have ability to open it up again. Because I always look at the future. Everything fails. Everything breaks. Once you do that, once you get it open, then make sure you pull out the 3 wheels. Here you go. Put that in there so you can see that it actually spins. See? Got some snow on it still. So, there you go. But anyhow, so now you can see all 3 of the spinning things spin like they're supposed to. I'm not going to press them on completely until we put the face back on and then I glue this piece down. This one has to be in there because that is the axle for this. So if your motor fails, heat this up, pop it out. Once it's out, remove the screws, and if you can finagle this out over the plate, great. If yours has a huge amount of resin down here that you can't get, and you're just distorting your plate, or you're going to chip or crack the porcelain, distort the plate, rip it out, and make a new one. You saw you can use an old jewel case. Any plastic about as thick as one of these. It doesn't have to be a jewel case. It could be a cassette tape case. It could be some random piece of plastic from a toy. The battery cover from the battery packs that go on Department 56. Anything that's lying around would work. And once you do that, you can make a new one. Cut it oversized and trim it to fit. It's better to go big and then trim it small than to go too small and have to make it another time. Once you get it out, unscrew the face, and I would solder the new motor to the backing. So that way you have a good connection, no extra wire that you have bundled up inside. Now, if you don't have that ability, splice it using different methods, twisting it, heat shrink, electrical tape, butt connectors, hot glue, liquid electrical tape, so on and so forth. Whatever you need to do to make it work, but make sure that you tuck it off to the side, so that way the wheel on this end or on this end that protrude past the white backer plate, one of the gumdrops doesn't grab it and pull it up and do this, because then you're going to possibly break the motor and have to do it again. As you saw, it had plenty of lead to pull it out and do most of the work, which is amazing because they're never like that. Clean your hubs if there's any debris on them, like fake snow or dust, hair, etc. If you have to replace the motor and you cannot find the same exact motor and you get a long shaft like I got, drill the shaft all the way down and then do the cut the shaft to length. As you saw, that's where my red marker is, right there where I had to mark the shaft, so I knew it was at the right position, so it comes all the way through. Now when I pressed on the wheel was slipping, because when you press and unpress things, it changes the tolerance. So I put a very, very thin coat of super glue on the shaft and then slid the wheel on and moved it back and forth, so it has a very thin bond that's still breakable. You can also wrap the shaft in very thin tape, such as electrical tape, but that's usually too thick. I forgot what it's called. It's the yellow tape they wrap wires with, or transformers. Personally, I would just use glue, because you can always heat the shaft up and break the glue or crack the glue by torquing the wheel. It's personal preference. You can pin it too if you want to get super fancy, where you put a keyway in it or put a pin through it. Once that's all done, do the reassembly. You can add a little dry lube. I use this from DuPont, and the dry lube you would put basically where the axle goes through here, and on this side, and on this guy here, and it just prevents it from binding. But remember, certain lubrications are excessive due to the fact that they will absorb dirt and dust, which is the problem with almost any lubrication. What I like about the dry film is once it's dry, it's like Teflon. It's slick, but there's no gumminess or stickiness for things to adhere to it, such as dirt, dust, and hair. So, again, personal preferences. So I'm going to go ahead and unplug it, since this doesn't come with an off-on switch. It would have been neat if they put one in this box. And glue this in, and then glue the face on, and put all the wheels back on, and then we'll see what it looks like in the low light, and see what it does as far as lighting and color. And we'll probably take more of this snow off. Seems to be everywhere. So, be back in just a moment with the completed, finished, fully reassembled product. Alright, it is back together. There you go, see? Nice and pretty. So here it is with its full functionality, lights and motion. Let me kill some lights. Here is low light. There's a little bit of light coming in from the window. So, the piece is now back together with a new motor and a new plate. So, it's not a bad looking piece. I'm not a Christmas person, but this piece actually looks really nice. It's got good colors. The gumdrops look like real gumdrops, which is actually pretty neat. The motion's back, so we got the conveyor belt. And what's nice about this piece is, excuse me, with a lot of pieces, if the motor fails, it stops the whole house. Well, with this piece, you can just unplug the motor and just have it light up. And then if you don't want the lights, you unplug that one. So this is kind of neat that this has the two powers. That's actually, it's both the same power going in. This is just the splitter. So it's 12 volts AC going into the splitter, and the splitter splits 12 volts AC here and here. Instead of splitting it inside the house, that's actually pretty neat. But that at least allows you, if the electrics break, you can disconnect it. So, but there we go, the Yummy Gummy Gumdrop Factory. How to open it up and repair it, and in the case of this one, how to modify it so it can work again. And what happens you do if you break something. Like Bob Ross used to say, there are no mistakes, just happy accidents. So the mistake of breaking the base plate, just a happy accident. So there we go. So we'll put it back in this box and get it back to its original owner. So that way they can give it, I think she said she was giving it to her daughter, but it broke, so she didn't give it to her daughter. So now she can give it to her daughter, and her daughter will have a functional gumdrop factory. So until the next one, thanks for watching.